Hello, this is my English speaking practice, and I'm working on coding problems. Today's problem is coding combination sum 3. Find all valid combinations of k numbers that sum up to n such that the following conditions are true. Only numbers 1 through 9 are used. Each number is used at most once. Return a list of all possible valid combinations. The list must not contain the same combination twice, and the combinations may be returned in any order. So let me take a look at example 1. K equals 3, n equals 7. So there is one valid combination, 1 to 4. They sum up to 7, and the length is 3. And for example 2, k is 3 and n is 9. So we have 3 valid combinations. And k is 4 and n is 1. There are no valid combinations using 4 different numbers in the range 1 to 9. The smallest sum we can get is 1 plus 2 plus 3 plus 4 is 10, and since 10 is greater than 1, there are no valid combination. Okay, and the k range is from 2 to 9 and n range is from 1 to 60. Okay. So the basic idea is to decide the number, to decide to use the number or not, one by one. So so it is, so we have to look at one by one and so I mean the first step is decide whether we use one or decide to use one or not to use one. So we have 2 options, and then for each path we have 2 options, use 2 or not. So this exploring states exponentially. So I think the DFS works for this problem, and we have to think 2 options. So we will use backtrack. So basically after searching the state, with 1, and after that backtrack here and remove 1 and restart to search for this path. So the pseudocode is like backtracking and it takes n is n increase 1 by 1 when we use it. N plus 1 and n is not good. I is the number that can we use, and k is the k means remaining number that can we use. So in the first path we choose it, so it would be decremented, and we take the target, and the target is updated like this because we choose I, so the I contributes to the total value, so we can update the target like this. And when we don't use it, the remaining still same, and the target is also don't change. So like this. So this is there is no backtracking, just I think this is just TFS. What is the base case? Target is 0. Oh, I see. We have to keep track of which ones we choose. So maybe we can have a list for store all possible paths, and also we have use path, which is list of integer to store the exploring path. So backtracking, yeah. So we will use backtracking because we have to update path for for each step. For example, when we choose the number I, we append it to the path, but after that we have to remove it from the path because we don't use the number I, so the backtracking works here. And when we have the target is 0, the current path is the answer. So and we have to deep copy, and if target less than 0, we return it. We cannot find a valid path anymore. So yeah. And also we don't have to comment out because this is a valid Python code. So let me call it if the target is 0. Target is 0 and remaining is also 0 because we have to use numbers that is specified by k, so we require to use specific numbers, and that sums up to target. Yeah. So this is a case when we can append the path to the answer, and if the target is less than 0 or remaining is less than 0, the path is not valid, so we return it. Yep. And this part is just backtracking. Yes. And also I is until 9, until 10, until 9, until 9. So if I is greater than 9, we return it. That's all. Yeah, let me think about example 1. And we have to start to backtrack. Here 1 kn, so the k is 3 and n is 7. And first we can append 1 and the next call with 2 and 2 to 7, 2 to 6. Okay, 2 to 6, add 2 and 3 1 314 and 314, append 3 and remaining is 0. Remaining is 0, target is 1. We call it and 5 negative value and negative value, so return it. Okay. Yeah, we always increment the I number, so this call will reach here, so there is no infinite loop. Okay, so I think this works. Correct. Is there any edge cases? The K is 2 to 9. Target is 1 to 60. No negative values. Each number is used at most once. Seems good. Let me test it. Great work. Okay. The time complexity and space complexity. The backtracking one, 2, 3, 4, 5, 6, 7, 8, 9. Two power of 9. Time complexity 2, because we call 2 backtracking for each call, per each call, and the depth would be 9, so 2 power of 9. And space complexity. Space complexity is so in this list we have all possible valid combinations. So the possible paths are 2 power of 9, and and roughly estimated those paths might be a valid answer. So the 9 times the combination's length is 9 at the most, so the 9 times 2 power of 9 9 means the length of one path at the most, and 2 power of 9 means number of possible combinations. Yep. Let me see the solution. 2 power of n in worst case, since which can be included more precisely, the number of valid combinations is boundary by okay, but good estimates. And space complexity for the recursion stack and current path storage, excluding output. Oh, why you can exclude output? Exactly. For recursion stack, the space complexity would be k, because there are k times recursion call at most. No. It must be estimated by 9, because when we don't use the number I, the k doesn't change, so the recursion stack might be k. Yeah, I think so. Okay. This is for the output, but for this process, the space complexity is is 9. For recursion call stack. Okay. Do next. Rectangle area given the coordinates of two rectilinear rectangles in a 2D plane. Return the total area covered by the two rectangles. The first rectangle is defined by its bottom left corner AX1 and AY1 and its top right corner AX2 AY2. The second rectangle is defined by its bottom left corner BXY BY1 BX1 BY1 and its top right corner BX2 BY2. Bottom left, top right, bottom left, top right. Okay. That seems too simple. So in this case, we can define the two rectangles with four parameters like this, and we have to return the area that covered by two rectangles, so the answer would be 3 times 2. Return the total area covered by two rectangles. 3 times 2. The answer is I see. The total, not and or condition. So it would be 6 times 4, 24. 4 times 9, 36. And there is duplicates, so 36 plus would be 54. Why? 4 times 6, 24. 24, 36, right? 9 by 4, 36. 9, 4, 36. And 6, 4, 24, 24. 60. And we have to subtract this area once because this is duplicate. So 2 by 6, it's 6. So 60 minus 6 is 40, 54. Why 45? Hmm? One, two, three. 1, 2, 3, 4. 12. 6. 6. 24. Yeah. 1, 2, 3. 27. 1, 2, 3, 4, 5, 6. 6 times 4. 24. 27 plus 24. 40, 50. Oh? 51. Something wrong. 24. 1, 2, 3. 27. 27. 1, 2, 3. 3. I thought I calculated this length is 4, but it's 1, 2, 3. Okay, so 24 plus 27 minus 6. So 45. Yes, correct. Okay, so just AX, just calculate AX. Oh, wait. The problem is how can we find this common area? It would be BX, distance between BX and BX1 and AX2, and AY1 between BY2. But we have to know which one is the which one is left, which one is at leftmost and at higher place. I mean we have to compare the smaller y. We have to compare y-axis to find a smaller y coordinate, and we have to compare the x coordinate to find the to find the larger x-axis because the common area common areas bottom left and top right I see. Oh wait, but let me think about patterns because there are several patterns. AX1, AX2, BX1, BX2. This is always true, and pattern 1 is like this. This case, there must be common area for x axis. Okay, so just two patterns. AX2, BX1, no common area. And we don't need to think about y-axis because we already know there is no common area. There is no area that covered by the rectangles because we can and we get to know based on the x-axis. So the condition for common area is wait. No. AX this pattern or B A this pattern. Because we don't know which one is bigger. And also there is a pattern, and must be so this means the box A inside box 2, box B. Okay, so there are 4 patterns, common area for x-axis. Okay, and we do the same for y-axis, and we can find the common area. We can calculate the area of common area. Okay, so yeah, so let's implement this. Yeah. This pattern Cx must be minus bx1, because bx1 is larger than ax1, so this is the base. This is the base x point, and yeah, which one is, yeah, either is fine, and we take the minimum one. Okay, and otherwise bx1 is less than ax1, so the cx is oh, I understand. So the minimum one subtract maximum one, bax1 and bx1. that makes sense. And cy is ay2 by2 minus max ay1 by1, because when we compare the 1 and 2 coordinate, 1 means left bottom and 2 means top bottom coordinates. So we always subtract from top right minus bottom left, and we have to take minimum 1 for top right and take maximum 1 for bottom left in order to get common area. Okay, so the common area is it's 0 at least, cx and cy. Yep. Yeah. This is the main problem, and then we just calculate the area 1 that would be ax2 minus ax1 times ay2 ay1, right? Yeah, this is the area 1 and area 1 a1 no a, yeah, a is the a's area and b is the b's area, bx2 minus bx1 times by2 minus by1, and the total area is like this, because C is calculated twice, so we subtract C at once. Correct. Sorry, cx might be negative value, and cy also might be negative value, and negative value and negative value might be positive value. That's not good, so I think we have to take care of negative value here and yeah, cx and cy must be positive value. Yep, great. Let's go. Good. Yep. The time complexity and space complexity are constant, obviously. Good. Okay, let me try next one. Basic calculator 2. Given a string s which represents an expression, evaluate this expression and return its value. The integer division should truncate toward 0. You may assume that given expression is always valid, or intermediate result will be in range of 32 integer signed integer 32-bit, and you are not allowed to use any built-in function which evaluates strings as mathematical expressions such as eval. Okay. S consists of integer and operators and separated by separated expressions. Oh, we don't need to care about priorities of operator. Separated by some number of spaces, so that means if there is no space, the multiplication and division is prioritized, but if there is space, it's like parenthesis, so it's like there is parenthesis, so in this case 3 plus 5 goes first and then divide by 2. That's not good. Why this is 5? 5 divided by 2 gonna be 2.5, but it forward, so this part would be 2 and 3 plus 2 is 5. Okay, I see. So I understand. I see. We have to split by the operators, so it be 3, 5, 2, and the operators is like this. So in this case, we find the multiplication or division, and that takes corresponding one and the previous value. So my idea is like this, and then the plus is happen, and it's gonna be 5. How about this? Let me see the result. Seven is expected. So this gonna be 2 and times 2. So 3 plus 4, that's 7. Okay, so let me see this case, and searching for the operations. To execute first. So in this case, this one is happen first. So the next state is like this. And this one is like this, so the answer is 7. Okay. Okay. So how to implement this? The length is 3 times 10 power 5. 15 as 32-bit integer. Okay. when we use list, let me see the step 1 to find the operators and find the corresponding numbers and the previous numbers. This is okay because we can get index. But how about this? How about updates? The result of calculation is 2. The previous value would be the place where the previous value exists is updated to the result, and then the following elements move shift left, have to shift left, right? So this is a reason why I'm going to find another solution. So I think I want to avoid this shift. After updates, how about update operator like this? And this is a list of integers, so we cannot update like this, but we don't care about this part because the corresponding operator is invalid. So when we look at this operator multiply, the value is 2 and we have to find the previous value, but it's not good, so we go to the next and we can find 2 with valid operator. So it's like it's gonna be like this, and the final part is like this. Yeah, but the problem is to find the valid operator. This takes linear time additionally, so it's similar, it's same as shifting the list because it takes a linear time. So But I think inevitable inevitable when I introduce the linked list here, the problem can be solved elegantly, but I think it's too much. But the length is 3 times. So how about using dictionary for instead of linked list? So the information we have to keep track of is the index, the information we have to keep track of is the previous value for each remaining numbers and operators. For example, in this case, this part is calculated and like this. So at this time, this element should find this one, because this one is invalid. So the thing is 0, 1, 2, 3. So when we calculate number at index 2, the index 3 must connect to index 1. Okay, so when we but for the loop, for the first time, we are going from left to right, and if the operator is division or multiplication, we calculate it. So we have to keep track of valid final index. We just use previous index. So I mean prev is 1 because when we look at this one, prev is 1, okay? And when we look at this one, prev is still 1 because this one is not valid. This one is a value to be calculated with this, okay? So prev is still prev is 1, and when we finish the loop, first loop, there is only plus or minus operators, okay? And then we just execute it. Prev is reset to 0. If there is another operators, just do the same for plus and minus. So we just loop twice for division and multiplication, and for addition and subtraction. The time complexity be n. Yeah, I think this works. So let's implement it. But I'm not sure how to split this. Let me see how it goes with this. Okay. Split plus separator multiple dimi import regular expression module and R single quote. And plus is plus minus multiply division. Let me see. Not split it. plus I forget. Like this. Regular expression. Oh yeah, vertical bar. Vertical bar is RE split. Okay. And pass S. Okay. Nice. Oops. I see. For operators, zero to 9. Zero to 9 more than 0. Repeated more than 0. Replace. Yeah. I got numbers and operators and we can parse it and we do loop twice, okay, because there is priorities of operators. So the first, multiplication and division, and we have to keep track of the valid previous value index. And for in range len num and ops I in multiplication or division, we do it, and otherwise we skip it. But we have to check if the operation is valid or not. Yeah. Believe I. Oh wait. Let me. We have to check all of operators for each because the process is changed. So in this case, num_split I would be updated like the nums I, okay. So I think like this, and when we calculate once, I want to update like this, but I think this is not necessary because we don't see this operator later, so it's not necessary. This case, divide by nums I and truncate toward 0. And when we look at these value, these operations, Believe I is I. Otherwise, we don't need to do anything. Step 2. We just update the numbers. I believe I. Maybe we always use number at 0 because yes, we always calculate the number with the first one. And return num0. Let me try. Cannot multiply sequence. Oh, I see. We have to convert it to int. Good. Great. Is there any edge cases? Yes, is one. Okay, submit it. Not bad. But it seems to be solved by stack. Stack stores all signed numbers or partial results at the end. We just sum up everything in the stack. Okay. Remove spaces for convenience. Okay. Enumerate S and get the character. Okay. Below numbers handle multiple digits like okay. Let's see. When we reach an operator or the end of a string, apply the previous operator to the current number. I see. Oh, really? But in this case, 503, the addition happens first, right? Because 3 is appended and 500 is appended. I see. Yeah, addition doesn't occur because just append to the stack. So the stack is like 3 and 500. And when we see the multiplication or division, the last element will be used for calculation, so we can make the division and multiplication occur first, and finally sum stack. It's like addition and subtraction. Subtraction is expressed by negative value, so it doesn't matter. So sum works here. Sum function works here. Okay. So this is a step 1. Okay. But it's okay. Not bad. So What to do next? Okay, finish for now. Yeah. Finish for now. See you again. See you later.